Is immortality possible with technology? The last frontier of humanity. What if death wasn't an inevitable fate, but simply a technical problem waiting to be solved? A glitch in the biological system that, with the right knowledge and tools, we could patch, upgrade, and eventually overcome. For millennia, this question belonged to the realm of mythology, religion, and science fiction, but it has now stormed into Silicon Valley labs, big tech boardrooms, and the world's most prestigious neuroscience conferences with unprecedented force. It is no longer an abstract philosophical debate. It's an engineering challenge backed by a multi-billion-dollar budget. The core conflict is deep and paradoxical. The same species that has struggled to survive in a hostile world is now proposing to redesign the fundamental rules of existence, challenging the natural life cycle and unleashing a storm of unprecedented ethical, social, and existential questions. Are we on the cusp of humanity's ultimate liberation or the most arrogant of our failures? This journey isn't to the stars, but deep into our own selves, our minds, and our definition of what it means to be human and to be so forever. Chapter 1. The Millennial Dream. From elixirs to algorithms, the obsession with cheating death is as old as the awareness of our own mortality. Egyptian pharaohs built pyramids, monumental tombs, designed not just as eternal dwellings, but as resurrection machines to ensure their rebirth in the afterlife. In ancient China, Taoist alchemists like Ji Hong tirelessly sought the elixir of life, experimenting with cinnabar mercury sulfide, with ironically, fatal results. The search for the Holy Grail or Panstik as fountain of youth are all manifestations of the same human impulse, the desire to perpetuate the self. However, the crucial turning point came in the 20th century. Until then, life expectancy at birth had remained relatively low, hovering between 20 and 40 years for most of human history. The causes of death were predominantly external: infections, famine, trauma, the medical revolution of the last 150 years with hygiene. Antibiotics, vaccines, and surgical advances changed the rules of the game. We didn't conquer death, but we massively postponed it. Global life expectancy doubled, rising from around 30 to 35 years in 1900 to over 72 years today. This success brought us face to face with a new enemy. Aging itself. Aging stopped being seen as a mysterious and inevitable process and began to be understood as a disease, a complex but potentially treatable medical condition. This is the first great revelation of our story. Immortality, or more precisely, indefinite longevity, is no longer a mystical dream. It is a field of biomedical research with quantifiable parameters. The goal is no longer to find a magic potion, but to decipher and hack the 9 hallmarks of aging, identified by scientists Carlos Lopez-Otin and others in 2013. These include genomic instability, telomere attrition, epigenetic alterations, loss of proteostasis, deregulated nutrient sensing, mitochondrial dysfunction, cellular senescence, stem cell exhaustion, and altered intercellular communication. Each of these points represents a corrupted line of code in life software, and where there is code, there is potentially a patch. 2. The 3 paths to eternity: body, mind, and machine. Current research is structured around 3 main paths, each radically different in its approach but convergent in its ultimate goal: extending healthy life indefinitely. 1. Longevity escape. Conquering the biological body. This path is the most direct, treating the human body as a biological vehicle that wears out and needs maintenance, repair, and eventually parts replacement. Its premise is that if we can prevent or reverse accumulated damage at the molecular and cellular level, we can maintain the organism in an optimal state of health indefinitely. Genetic and epigenetic therapies. Companies like BioViva, founded by the audacious Elizabeth Parrish, are experimenting with gene therapies in humans. Parrish injected herself with a virus vector carrying genes for telomerase, the enzyme that lengthens telomeres and myosin inhibitor to prevent muscle loss. She reported a rejuvenation of 20 years in her telomeres, although the case, being N equals 1 and self-administered, is scientifically controversial. The idea is to edit our DNA to activate protective genes and deactivate deleterious ones. CRISPR-Cas9 technology, a precise gene editing tool that acts like molecular scissors, is the great hope here. Senolytics and cellular cleansing. Senescent cells are zombie cells that accumulate with age. They don't die but secrete inflammatory substances that harm healthy neighboring cells. Senolytic drugs are compounds designed to selectively locate and eliminate these cells. Experiments in mice have been spectacular. Elderly animals treated with these drugs showed improved heart, kidney, and muscle function, more rejuvenated fur, and an increase in their lifespan. Companies like Unity Biotechnology are leading human clinical trials to treat age-related diseases like osteoarthritis, cellular reprogramming. The work of Nobel laureate Shinya Yamanaka was a conceptual earthquake. He demonstrated that by introducing 4 transcription factors, the proteins OCT4 SOX2 CLEL4 and C, now known as Yamanaka factors, an adult specialized cell like a skin cell can be reverted to a state of pluripotency, that is, to a young stem cell capable of becoming any cell type in the body. Scientist Juan Carlos Belmonte of the Salk Institute has gone a step further by applying short cycles of these factors in progeroid mice, which age very quickly. He managed to reverse signs of aging and extend their life by 30%. The idea isn't to revert to an embryo, but to reset the epigenetic clock of adult cells, so they are functionally younger. It's the equivalent of a CTRL plus Alt plus Delete. For the organism narrative turning point 1. The results in animals are promising, but the leap to humans is a cap. Uncontrolled cellular reprogramming is, by definition, the mechanism that generates cancer. Can we find the exact point of rejuvenation without causing tumors? The first human trial in this field, initiated by the company Altos Labs, funded with billions by sheiks and tech magnates, will mark a before and after. Chapter 2. Mind uploading and the singularity. Escaping the body. If the biological path seems too slow and risky, there's a more radical option. If the body is inevitably mortal, why not abandon it? This is the proposal of whole brain emulation. The concept is to transfer consciousness, memories, personality, everything that constitutes yourself from a biological substrate, the brain, to a digital one, a computer or a server cloud. The theoretical process would have several phases. 1. Cryopreservation or vitrification. The brain is perfectly preserved using ultra-freezing techniques to prevent the formation of ice crystals that damage teeth. Companies like the Alcor Life Extension Foundation already offer this postmortem service, preserving bodies or heads neuropreservation, with the hope of a future technological resurrection. 2. Mapping, using future nanorobots or nanometer resolution imaging techniques. The brain would be scanned to create a complete map of its connectome, the totality of neural connections, synapses, and their states. It is estimated that the human brain has about 86 billion neurons and more than 100 trillion synapses. The amount of data is astronomical, on the order of exabytes. 3. Simulation. This map would be uploaded into a computer simulation powerful enough to emulate the electrochemical dynamics of the brain. The theory says that if the structure and function are replicated with sufficient fidelity, consciousness would emerge in the new substrate. You, or a copy of you, would wake up in a virtual world. Proponents of this view, such as Ray Kurzweil, predict the arrival of the singularity around 2045, a point where artificial intelligence will surpass human intelligence and the fusion between biology and technology will be complete, allowing for this type of transcendence. For them, death is a data loss problem. The solution is to create a backup. Narrative turning point 2. Here arises the paradox of identity. If a perfect digital copy of your brain is created, is that being you, or is it simply a digital doppelganger that believes it's you, while your original biological consciousness remains in your body and eventually dies? It's the modern equivalent of the teleportation problem in philosophy. Would you get into a machine that creates a perfect, immortal copy of you in a digital paradise, but which requires the destruction of your original brain in the process? The answer divides the community. Chapter 3. Cyborgization and Biohacking. The gradual fusion. The third path is a pragmatic middle ground. Don't replace the body completely, but constantly improve it and integrate it symbiotically with technology until the boundary between natural and artificial completely blurs. It's not about an abrupt migration, but an evolution. This is already happening on a small scale. Cochlear and retinal implants that restore and in the future could enhance senses, pacemakers and deep brain stimulators that regulate critical bodily functions, bionic prosthetics, controlled by the mind, which restore mobility and could surpass natural human capabilities. The next step is nanorobots. Visionaries like inventor Ray Kurzweil, also here, predict that in the 2030s and 2040s, we will have nanobots circulating in our bloodstream. Their mission would be multiple. From performing real-time diagnoses and precisely administering drugs to repairing damaged tissues, eliminating atherosclerotic plaques, and wirelessly connecting our neocortex to the cloud, expanding our memory and cognitive capacities, we would stop being Homo sapiens and become Homo cyberneticus. This gradual fusion would solve the identity problem more elegantly. There is no original UNA copy, there is a you that is continuously improved and extended. Death would become a process of technological obsolescence, not a biological event. As long as you can update your parts and back up your consciousness, you could continue. 3. The tech giants in the race for eternity. This is not a fringe field of research. It attracts colossal amounts of capital and interest from the planet's most influential figures and companies. Jeff Bezos and Altos Labs. The Amazon founder, along with others, has invested billions of dollars in Altos Labs, a biotech institute that brings together the world's best scientists in cellular including Shinya Yamanaka himself. Its stated goal is to understand and reverse aging. Larry Page and Calico California Life Company. Google co-founder created Calico, a research and development company whose explicit mission is to address aging and associated diseases. It operates with a very long-term time horizon and a budget that is opaque but believed to be enormous. Peter Thiel and the Methuselah Foundation. The well-known PayPal investor is a fervent advocate for fighting death. He has funded research in cryonics and organizations like the Methuselah Foundation, dedicated to radically extending a healthy human life. Brian Johnson and Blueprint. The tech entrepreneur spends millions a year on an extreme regimen of diets, exercises, and supplements with over 100 bodily variables measured daily with the goal of reversing his biological age. It is the most extreme case of quantified biohacking. The narrative here is clear. For the tech elite, death is the last market to disrupt, the last bug to fix. They see biology as a legacy operating system, full of coding, errors, bad genes that can be hacked. Narrative turning point 3. This raises a terrifying social question. Will immortality be a luxury only for the ultra-rich? If rejuvenation therapies or cryopreservation cost millions, we could evolve into a new species division. A class of immortal, ultra-rich, and another of mortal, natural humans condemned to age and die. The implications for inequality, pressure on resources, and social structure would be dystopian. Chapter 4. The ethical, philosophical, and practical barriers. Beyond the technical challenges, the path to immortality is fraught with obstacles that question the very essence of our humanity, the problem of identity and consciousness. As we anticipated, even if the technology works, does consciousness survive? Neuroscience still doesn't have a unified theory of what consciousness is. Is it an emergent phenomenon of neurocomplexity? If so, perhaps it can be or does it have an irreducible, inherently biological quality? If so, mind uploading would only create a philosophical zombie, a simulacrum without qualia subjective experience, overpopulation and resources. The planet already suffers from enormous demographic and ecological pressure. What would happen if no one died? Even if the birth rate plummeted, the simple fact that the population would stop renewing itself would pose unfathomable problems of space, food, energy, and waste management. Who decides who can have children? Would a system of one immortal, 0 children be implemented? Stagnation and existential boredom. Much of human creativity, urgency, and passion stems from our finite time. Death gives life meaning. What motivation would a 500-year-old mind have? Would we not fall into infinite apathy and boredom? The philosopher Bernard Williams argued that immortality would be intolerably boring, as we would exhaust all possible experiences and our characters would become fixed and unable to change. The existential risk. An immortal humanity is a humanity playing a single game. A single disastrous man-made pandemic, a nuclear war, a hostile artificial intelligence could end the entire species forever. Individual mortality has, in a way, been an evolutionary safety mechanism for the renewal and adaptation of the species. The psychological impact. Could the human mind endure centuries or millennia of memories, the accumulated trauma, the loss of mortal loved ones? Brain plasticity might not be enough, leading to madness or a total emotional disconnection. Narrative turning point 4. The search for immortality could ultimately be an exercise in extreme narcissism. Does it reflect a pathological fear of death or an inordinate love for oneself? Many spiritual traditions see the acceptance of mortality as a key to a fulfilling life. Are we losing something deeply human in this race? Chapter 5. The future? Utopia? Dystopia? Or simple science fiction? As of today, absolute immortality remains science fiction, but extensive health longevity. Longevity escape velocity, a concept coined by gerontologist Aubrey de Grey, is not so much. The idea is that if we manage to extend a healthy life by 1 year for every year that passes, we will effectively achieve biological immortality, because you will always be one step away from the next therapy that will give you another year and so on. The most optimistic prospects place key milestones in the coming decades. Nanobots in the blood by 2030, brain-to-cloud connection by 2040, and the Lon-4 singularity by 2045. The most skeptical, like biologist Francois Ballou, point out that aging is too complex and intertwined a process to have a silver bullet that solves it. They argue that we will likely be able to extend a healthy life by a few years, perhaps decades, but not indefinitely. The most likely future is not a world of digital immortals, but one where a healthy life expectancy is gradually extended to 100, 120, or perhaps 150 years thanks to a combination of genetic therapies, senolytic drugs, and lab-grown replacement organs. Death will still exist, but it will increasingly be a choice, or an accident rather than a sealed fate. Conclusion: the death of death or the birth of a new species. We have traveled a path that goes from the alchemist's elixirs to Silicon Valley algorithms. The question, is immortality possible with technology, does not have a simple answer. Technically, advances in cellular rejuvenation are real and promising. The emulation of the mind, although speculative, does not violate any known physical laws. Therefore, in a strictly theoretical sense, yes, it seems possible, but the practical and philosophical answer is much more nuanced. Biological immortality clashes with the overwhelming complexity of our organism and the risk of cancer. Digital immortality crashes against the unresolved mystery of consciousness and the paradox of identity. The true legacy of this search may not be conquering death, but redefining life. It is forcing us to question what makes us human. Our mortal flesh, our continuous consciousness, or our ability to change and grow within finite limits. We are playing with forces that could lead us to a golden age of unprecedented health and prosperity, or to a dystopia of eternal inequality and existential stagnation. The final reflection is inevitably personal. Given the possibility, however remote, that death is optional, what would you choose? Would you accept the natural cycle with all its beauty and its pain? Would you opt to extend your biological life as long as your mind can bear it? Would you risk a digital copy, betting that consciousness will transfer? Or perhaps the most important question is, in a world of infinite time, what would you do with your day-to-day? Technology can provide the tools, but the answer to these questions will define not only our future as a species, but the very meaning of a life well lived.